Okay, so today we're going to talk. Yesterday we talked about is something a function, and today we're going to say is the function linear? So basically, the question is it a line? Okay, so most of your, if not all of your assignment is going to be centered around is this a linear function, yes or no? Um, and it'll be represented in a bunch of different ways. And then toward the end, we'll do something a little bit different. But um, so, really simple. Yes, that's a linear function because that's a line. No, that's not a linear function because it's not a line. Okay, really simple for that part of it. Okay, so you'll have some graphs to look at. It's just yes or no, really quick, really easy. Okay, um, then we're going to have some charts to look at. And we'll look at like charts like this in a bunch of different chapters. And really, I can't think of a chapter where we're not going to at least start off in the same way. So what we're going to do is just look for a pattern of the x's. Well, these all go up by 3. And then look for a pattern in the y's. These all go down by 6. Okay? And then I'll come back to is it linear or not in just a second. So let's do another one. Okay, so the x's go up by 2, and the y's go up by 7, then up by 11, then up by 15. Okay, so this first one is yes, it's a line, because the x's have the same number and the y's have the same number, not the same like together, like 3 and 3 or -6 and -6, but it's all the same. Okay, on the second one, it's no, because the x's do go up by the same number, but the y's go up by different numbers. There's a pattern to it. 7, 11, 15, those are all kind of go up by 4, but that doesn't make it a line, it makes it a different shape. Okay, so when you see the chart, look for the pattern in the numbers. Okay, all right, then the next thing, it's going to give you some equations and wants to know is it a line. Okay, so it's almost easier to look for what's not a line than it is for what is a line. So if it's not a line, like what we don't want to see. So it's not a line if you see any exponents. if you see any square roots, let me bring that down to the next line. If you see x and y being multiplied together, if you see x in, oops, it's x or y. X or y in the denominator. And lastly, anything that is x equal a number. And I'll get into that more next week when we look at some graphs of lines. But for now, just memorize it. X equals. So if you saw, you've done equations of lines before. Like you've done y equal mx plus b. So if you had y equals 2x minus 6, that's a line. If you had 2x plus 4y equals negative 10, that's a line, because you don't see any of that stuff up there. Okay? If you saw x equals y squared plus 4, no, because of the exponent. If you saw y equals, I'm going to take that back. Okay, I need to amend something. I didn't add in enough information. Back up here under this the square root part, the x can't be under the square root. Okay? So if you had like this, it would be no. But if you had this, it would be yes. So pay special attention to, is it a number? A number's okay, because the square root of 4 is 2. I can do that. The square root of x, it's going to create a curve. Even if you plugged in a number like 4 that has a square root, and 9 that has a square root, and 16 that has a square root, it's going to create a curve and not a line when you do that. Okay? So you'll have a section of problems that have just a bunch of equations listed, and it wants to know yes or no. Is it a linear function? So you're just looking for, like I said, any of those, like exponents, x under the square root, x and y being multiplied together, x or y in the denominator, those all make it a no. An x equal number also is a no. Okay? Alright. And then the last thing you're going to look at is what's called discrete or continuous domain. So on a graph, it's really easy to tell. So if you're looking at a graph, and you just have points, that's discrete. If you have a line that's connected, then that would be continuous. Okay. So then there's a couple of them that are graphs. That should be really easy to look at. And then the other ones are going to be charts. And it's going to give you some situations. So on the situation one, can I do half? That's the question you want to ask yourself. Can I have half? So if it talked about having like shoes, can I have half a shoe? No. So that would go to discrete. If it talked about time in any like way, shape, or form, can I have half a minute? Can I have half an hour? Can I have half a month? Can I have half a year? Can I have... Yes. Continuous. Okay. So, and not like, so, is it possible to have half a shoe? Sure it can. You can cut a shoe in half. Okay, I have half a shoe, but it doesn't work the way that it should. So, don't get super technical on that and say, well, technically you can have... Okay, you're right, but that's not what they're after. Okay, so if it said, like, can you have half of a ball? Well, yeah, technically you can, but it doesn't work like a ball anymore. It's messed up. So that would be discrete. Okay, so the last four are a chart. Okay, you want to look at the input or the X information. Okay, that's what you want to focus on for the situations. So one talks about bags, one talks about years, one talks about time, one talks about relay teams. And so the answer is either going to be discrete or continuous. So again, not a whole lot of work to really do, to be honest. So you do have like 27 problems or something, but they're all yes or no. Are they linear? Is a ton of them. And then the last 6 problems are continuous or discrete domain. So you're just looking at it, and then you should have the answer within 15 seconds. So it still should only take you 20 minutes maybe to do the whole assignment, if that. So, all right. So remember, functions from yesterday, is the X number different? That's the big key question. And then today, is something a linear function? Means, is it a line? And then there's a few different ways to tell. So, all right, have a great rest of your day, guys, and we'll see you tomorrow.